Another important result, we have the intermediate value theorem. So what are we saying here? We are saying that if f is a continuous map and gamma is a point in between f of a and f of b, then there exists a c in the interval ab such that f of c is equal to gamma. So how can we interpret this? We have our interval. Now this is my interval from a to b. This is the interval AB. Then we also have f. This is f mapping this interval. It's mapping that interval to R, to a subset of R, which is also an interval. So here we have f takes this to the image. So here we have f of b, and this is f of a. So what are we saying? If we have something of this sort and gamma is a point in here, gamma is a point between f of a and f of b, then there exists a c. If gamma is in here, then there exists a c from the interval ab such that f of c is equal to gamma. What does this imply? In simple terms, in other words, any value in the middle of images, any value, because we have gamma is a value in the middle of images. Any value in the middle of images is an image, of a certain object. Any value in the middle of images is an image of a certain object. There exists a c such that f of c is equal to gamma. So how can we prove that? Let us see how this can be proved. So we are going to let this be a continuous map. Let that be a continuous map, and gamma be a point such that f of a is less than gamma is less than f of b, Then we want to show that there exists a c such that f of c is equal to gamma. Now what do we observe that? We observe that AB is an interval. F continuous. AB is an interval, and f is continuous. So this implies that by the previous result, an interval connected is an interval. Maybe I should also add this. Is an interval, hence connected. What else? F continuous. This should imply that the image which is f of this, the image which is f of this is a subset, the subset of R, hence connected, the subset of R which is the subset of R which is an interval, the subset of R which is an interval, hence connected. Is a subset of R which is an interval, hence connected. So we have this being connected. It is something which is connected, subset of R which is an interval, hence connected. So since it is an interval, also, so this is the image of this interval. This is the image of this interval, and f of A and f of B are images of A and B respectively. Then also, since they are images of A and B respectively, we have f of A and f of B being members of this interval. They are members of that interval. They are members of that interval, and since f of A is less than gamma less than f of B, since gamma is a point in between these two, then gamma also lies in the interval, this one. Gamma is an element in there, is an element in this interval. Gamma is an element in this interval, and to be there, since gamma is an element of this interval, to be here, since gamma is an element of this interval, so gamma to be in there, there exists, to be there implies that there exists a C, in the object FP such that f of C is equal to gamma. That f of C is equal to gamma. So that is the proof of the intermediate value theorem.